Okay, so this next topic number 3, will be about complex numbers. Complex numbers are numbers that are not real. Well, not real doesn't mean that it's not a number, but we're going to show you what makes a complex number a complex number. Before we start, let's evaluate those numbers. Radical of 9. So the radical of 9 equals 3 because 3 times 3 equals 9. So when you take the square root, it equals 3. How about the square root of 5? Well, there's no such number that you can multiply by itself. I mean, integer. There's no such natural number to multiply by itself to give you 5. So square root of 5, you're going to need to use your graphing calculator and approximate this number. So square root of 5 would be 2.23 60 67 97 and 7. So it keeps going. So this is not a rational number because it's not a repeating decimal, and then it's indefinite. It's not a rational number, but at least it's a number. Now, what happens to when you have the square root of a negative number? Now, when you have the square root of a negative number, well, remember when we were looking for the square root of 9, we were looking for another number that when you multiply by itself, like 3 times 3, it's 9. Just like if you have square root of 4, it's 2 because 2 times 2 is 4. So basically, when you're looking for the square root of a number, you are looking for another number that multiplies itself to give you that other number. But there's no such number here in the case where you have a negative number, because you never can find one single number that multiplies itself that will give you a negative number result. So there is no such number such that there's no number x. If you multiply by x, that will give you negative 9. No, there's no number like that. Because if let's say x is negative 2. Let's say x is negative 3. Well, I would expect this to be positive 9, because times itself would be positive anyways. And if it was positive 3, it would still be 9. So that makes the radical of negative 9 not a real number. So basically, I can tell you what square root of negative 9 is not, because it's not a real number. But we are not able to tell you what it is now. But at least we know one thing it's not. Same thing for square root of negative 5. It's not a real number. Because if it were to be a real number, then we would be able to find its square root, just like we did for 1 and 2. So basically, what we want you to remember is the radical of a number exists only if this number is a positive number. So square root of a exists as a real number if and only if a is positive. If it's not positive, then you don't have a real number. Now let's talk about the definition of I. I becomes the next element in mathematics that I'm going to introduce to you. I equals the square root of -1. I is that number, weird number, we can say, that is the only number that is the square root of a negative number. Its name is an imaginary number. That's why it's called I, imaginary number. Now, all numbers written with an imaginary number is called a complex number. Complex numbers. So we start introducing complex numbers with you. Now, earlier we couldn't solve square root of -9. We couldn't solve square root of -5, but it looks like we can now. The fact that we know we can talk about imaginary number that's square root of -1, and also we know that a number cannot be a real number, but also still a complex number. So that said, square root of -9 can be written as square root of -1 times 9. And if we separate the radical, it would be square root of -1 times square root of 9. Square root of -1, we know that this is I, right? So that's I square root of 9. And square root of 9, we know it's 3. So basically, square root of -9 is 3i. Same thing here. That's square root of -1 times 5. That equals to square root of -1 times square root of 5. I would prefer keeping square root of 5 as a radical instead, because I don't want to go here with this bunch of decimals. So I'm just going to keep it square root of 5. But we know square root of -1 is I, so that's I square root of 5. I prefer to keep the I in front instead of square root of 5i, because it's not inside of the radical. And sometimes when you student writing, you may keep it inside and it makes a whole different thing. So whenever it's a radical, I would suggest that you keep it in front of the radical. So here we have square root of -8. So that's the square root of -1 times 8. That equals square root of -1 times square root of 8 is 4 times 2. So that's I square root of 4 times square root of 2. Square root of 2, I mean, the reason I write 8 as 4 times 2 because square root of 4 is known. So I would rather writing it in simplified format. So square root of 2 is not a perfect square, so we can't, but we don't want the decimals. So we're just gonna keep square root of 2. But square root of 4 is 2, so that's 2i square root of 2 for square root of -8. So basically, the general rule would be if a is a positive number, a positive, then square root of -a is I square root of a. That's your general. And by definition, a complex number is in general form written as a plus bi, or a and b are real numbers. A and b are real numbers, but a plus bi will not be a real number because it has I, so it's a complex number. Note that number has two parts. Complex numbers has a complex number has two parts. A real part, that's the A value, and an imaginary part, that's the BI. Also note that if B equals 0, the complex number is automatically a real number, right? If B equals 0, you automatically have a complex number that is also a real number. That's it. Let's explore this. Remember, if it's a complex number, it always has A and B, the imaginary part and the real part. Now I have these numbers. I'm gonna need you to tell me whether you have a complex or a complex number or not. For the first one, we have 2 minus I. Is that a complex number? Yes or no? I give you some time to answer. You probably said yes. Now you said yes. What is A? You said A is 2. And what is B? No, B is not negative I. B is a coefficient of I. That means B is -1. Next, the second problem. 3I. Is that a complex or not a complex? You said yes or no. You're thinking your answer should be yes. What is A? A would be the real part. If you don't see it, that means it's 0. And then the imaginary part, which is the coefficient of I that I'm looking at, here is 3. Number 3, 5. Is that a complex number or not? Your answer should be yes. Sorry if it was no. Now, what is A? A would be the real part. Well, I only see a real number, so that's 5. I didn't see an imaginary part. That means the B was 0 because it was only the real part. And finally, 4. 0. Is that a complex number? Well, your answer should be yes. Sorry if it was no. What is A? Well, A is 0. Also, B is 0. In conclusion, all real numbers are complex numbers. It's like complex numbers, it's like an extension of real numbers. Because I showed you here that all real numbers are complex numbers, but not all complex numbers are real numbers, because 2 minus I is not a real number because it has I. Not all the complex numbers that don't have I will be the real numbers. All the real numbers all of the real numbers are complex numbers without I, with B equals 0. Equality of two complex numbers. Two complex numbers are equal if real parts are the same and imaginary parts are the same. Basically, if A equals, in this case, A plus BI and X plus YI are equal if A equals X and you have to have both of them, and B equals Y. Here's a quick example. I have the two complex numbers, 4 minus 5i and 7 minus 3i. Are they equal? Your answer should be no. And the reason is because because they have the two numbers have different part, real part, and different imaginary part. But even if they had one that was not different, say for example, you have imaginary parts are the same and real parts are different, it's not. You need to have both imaginary part and complex and imaginary part and real part same in order for two complex numbers to be the same. So for example, 2i, 2 plus b plus 2 plus 5i is 2 plus 5i. So if I have 2 plus 5i and then 2 plus xi, for these two complex numbers to be equal, we need to have 5 and x to be the same because we already have 2. So they have to have same real parts and same imaginary part. Here's an example here. I have, all right, let x and y be two real numbers. Find x and y such that the equation the complex number 2 plus 3, 3 plus 2x plus y minus 6i is equal to 2 plus 3i. So the first one here, this is a complex number, that's the real part. And then that's the imaginary part. So that's the real and that's the imaginary. So real should be equal real and imaginary should be equal to imaginary in order for you to get equal complex numbers. So basically I need 3 plus 2 x equals 2 and y minus 6 equals 3. So it says find x and y for these two complex to be equal. So I can subtract 3 on both sides. 2x equals negative 1, divide by 2, x equals negative 1/2. If I add 6, y equals 9. So these two complex numbers are equal if x equals negative half and then y equals 2, negative 1/2. Since complex numbers are numbers, right? So we can add and subtract, we can multiply, we can divide. So let's see how to add and subtract complex numbers. To add two complex numbers, a plus bi and x minus x plus yi. So we add them, we add real together, and imaginary together. So in this case, you would have a plus x plus b plus yi. And subtraction will be the same. That will be a minus x plus b minus yi. Let's practice. I want to add 2 plus 3i and 4 plus I. So that will be 2 plus 3, 4 plus 3 plus 1 coefficient of I. So this equals 6 plus 4 I. Over here, I'm adding, right? So that's -3 plus 19 plus 17 plus 21 I. So that's 16 plus 17 plus 21, that 38 I. Subtraction, that's a subtraction. We have 3 plus 4i minus -5 plus 6i. So that's 3 minus -5 plus 4 minus 6i. Minus -5 is plus 5, so that's 8. 4 minus 6 is 2, so minus 2i. And last example here is 13 minus 7i. It's a subtraction. 20 plus 59. So that's 13 minus 20 plus -7 minus 15i. So this is -7. We got -7 minus 15 is -22i. So that's how you add or subtract complex numbers. So you add the real numbers together and add the real parts together and the imaginary parts together. And same thing as with subtracting. Subtract the real parts together and subtract the imaginary parts together. Now let's look at multiplication of complex numbers. The multiplication of complex numbers is like FOIL. So we FOIL AX AY plus AYI XVI BY, or let's say BX instead. Yes, it's the same thing. BXI plus BYI squared. And we were not going to forget, so remember we FOIL. We're not going to forget that I equals square root of -1. Now, if we square both sides, I squared is -1. So that will be AX plus, there's I and I, we can factor I out. So AY plus BXI plus by times negative 1. So that becomes negative by. So finally, you're going to have ax minus by. That's the real part of the multiplication, plus ay plus bx I. Well, that's just trying to show you how to process. And we're going to do some examples. So we're multiplying 4i times 2 plus 3i. Well, because the first complex is one term, I mean the only imaginary part, so we can just distribute this as we would do for regular expression. So that's going to be 4i times 2 plus 4i times 3i. So that equals 8i plus 12i squared. I squared is negative 1, so that is 8i plus 12 times negative 1. So the complex number, this becomes the real part of the complex number, negative 12 plus 8i. Over here, we're going to FOIL, that's this, negative 12 minus 3i plus 28i plus 7i squared. I squared is negative 1, so that's negative 7. So that is negative 7 minus 12, that negative 7, which is negative 19. Minus 3i, it's going to be a plus, 3i plus 28. So 3i plus 28, I is 25i. So here's another example here. It's negative 5 plus 4i squared. So it's going to be negative 5 plus 4i times negative 5 plus 4i, right? And then FOIL this, that's going to be negative 20, positive 25. And then you're going to have negative 5 times negative times 4i, that's negative 20i. 4i times negative 5, another negative 20i. And then 4i times 4i, that's a positive 16i squared, which is actually negative 16 because I squared is negative 1. So 25 minus 16. 25 minus 16 minus 40i. 25 minus 16 is 9 minus 40i. And then finally, we're multiplying these three complex numbers, 3 minus I times 2 plus 5i times 1 minus 1 plus I. So we're going to multiply the first two first, and then we would multiply the result times the third. So let me multiply 2, that's 6. Since I'm going to multiply it by 1 plus I with the third one, and I'm going to break down the first one, the first two. That's 15 plus 15i. This is negative 2i. And then it's going to be minus 5i squared. We will simplify this. Minus 5i squared is positive 5i because negative 1, I squared is negative 1 times negative 5 is positive 5. So that's 11 plus 13i times 1 plus I. So we're going to perform this new, can FOIL this one. So 11 times 1 is 11. 11 times I is 11i. 13 times 1 is 13i times 1 is 13i. And then 13i times I is plus 13i squared, which is negative 13. So that's 11 minus 13, that is negative 2. And then 11i plus 13i, that's plus 24i. Now that's multiplying, that was multiplying complex numbers. Now let's see how to divide complex numbers. Now, when dividing complex numbers, we think about the conjugate of a complex number. So the conjugate of a complex number, a plus bi, is a minus bi. Just change the sign of the just change the sign of the imaginary part of the complex number. So some example here, 3 plus 4i conjugate is 3 minus 4i. Conjugate of 1 minus 5i is 1 plus 5i. And conjugate of negative 7i is just 7i. Conjugate of I, conjugate of I is negative I. Now, when dividing two complex numbers, this a plus bi divided by x minus x minus x plus yi, it's a plus bi divided by x plus yi. We just multiply and divide by the conjugate of the bottom. So that's x, we multiply and divide by x minus yi, x minus yi. Since we multiply and divide by the same expression, it doesn't change the actual complex. Let's practice. The first example here is 3 over 4 plus I. So we would multiply the 3 by the conjugate 4 minus I, and then multiply 4 minus plus I times 4 minus I. So this is A plus B times A minus B. So A plus B times A minus B is A squared minus B squared. We will not forget that. And that's how the denominator is always going to be. In this case, at least in this case. So that equals 12 minus 3i over 4 squared minus a minus I squared. I squared is -1, so -1 times -1 is +1, so denominator is 5. The top is 12 minus 3i. And it's always good to separate the denominator when it comes to complex numbers so you can see your real and imaginary part. So that's 12 over 5, which is the real, minus 3 over 5, which is the coefficient of I, which is, and then the imaginary part is -3i, -3/5 I. All right, so next example here. Multiply 2i and 1 plus i by 1 minus I, which is the conjugate. So 2i times 1 minus I, conjugate of the denominator, over 1 plus I times 1 minus I, which is a minus a plus b times a minus b. That equals 2i minus 2i squared, right? We distribute the 2i over 1 squared minus I squared. So that is -2 times -1, that's 2 plus 2i over, that's 1 plus 1, right? Because negative times -1 is plus. 2 plus 2i over 2, divide each by 2. So 2 over 2 is 1, plus 2i over 2 is I. Next problem. Well, I'm looking at 2 is a common factor here. I can factor the 2. 2 times 11 plus 3i. Same thing here. 2 times 2 minus 3i. That cancels the 2. And then I'm going to multiply top and bottom by the conjugate of the bottom. So that's 11 plus 3i times the conjugate of 2 minus 3i, that is 2 plus 3i. And then the denominator would be 2 minus 3i times 2 plus 3i. So that is going to distribute the top as FOIL, and then denominator, it's a minus b times a plus b. So that is 22 times 33i, plus 33i, 6i, and then 9i squared, which is -9, plus 9i squared, which is -9. Then the bottom is 4, which is, let me say instead, a squared, 2 squared minus 3i squared. It's not 3i squared. The 3i in parentheses and squared, because that's going to be 9i squared, or -9, because I squared is -1. So that's plus 9. So the bottom is, 4 plus 9, that's 13. The top, 22 plus minus 9 is 22 minus 9 is 13. 22 minus 9 is 13. And then 33i plus 6i is 39i. And if we simplify by 13, we separate the denominator. 13 over 13 is 1, plus 39i divided by 13 is 3i. So that's the answer for this division. And then finally, we multiply top and bottom. It's the same example here. So that's 3 plus I times the conjugate of the denominator 2 minus 2i over 2 plus 2i times 2 minus 2i. So that equals FOIL the top, 3 plus I times, let's FOIL this instead. So that's 3 times 2. 3 times 2 is 6. 3 times negative 2i, that's negative 6i. I times 2 is 2i. And I times negative 2i is negative 2i squared, which is actually positive 2. The bottom is a squared minus b squared. So that is 2 squared minus 2i squared. Simplify the top, that's positive 2, right? Because negative 2 times negative 1 is positive 2, I squared being negative 1. So positive 2, that's 8. And then negative 6i plus 2i is negative 4i. The denominator is 4 minus 4i squared, which is negative 4 times negative 1, positive 4, plus 4 is 8. The bottom is just 8. We can separate the denominator, 8 over 8 minus 4 over 8i, simplify, 1 minus 1/2 I. So that's how you divide fractions. I mean, you divide rational complex. That's how you divide complex numbers. I'm sorry, complex numbers. You multiply the top complex by the conjugate of the bottom. And the conjugate is the when you change the sign of the imaginary part. A plus bi, you change the sign of bi. If it was negative, turns positive. If it was positive, turns negative. And multiply top and bottom by the conjugate. Now, here are some examples. Remember, whenever you have a rational number, whenever you have a radical number that has negative under the square root, this can create a complex number for you. And that's the situation that we're going to deal with. So you cannot just multiply. Here, this is going to be square root of negative 1 times square root of 9 times square root of negative 1 times square root of 16. So that's I and that's I. So that's I times 3, or 3i. It's 3i times 4i. Agree? So basically that's 12i squared, which is negative 12. And obviously, if you did just multiply this inside of the radical, it would have given you positive 12. So you gotta respect the I rule, the rule of a complex number here, in order to get the right solution, which is negative 12. So the same thing here. We're gonna distribute this. But before that, let's do this. That's I square root of 6 times I square root of 15 plus square root of 10. Now we're going to distribute I squared to 6, which is now I squared square root of 6 times 15 . Well, let me write it as 6 times 15 here, because we may be able to simplify. And then plus, we distribute this. That is the square root of 6 times 10. Okay. Now, we may want to simplify this as well. So we have, this is 3 times 2, and this is 3 times 5, right? You have 3 times 3, which is 9. So we can pull out a 3. And then this is -1. So that's -3 square root of 10, right? And then here, that's 2 times 3, and then that's 2 times 5. We can pull out a 2, so that's +2, and then 15, square root of 15. Over here, we have -25 square root of negative, let me put, so we remember 50 is 2 times 25, right? So that is plus okay, -25 plus square root of -1, or just I, square root of 2 times square root of 25 over 15. So that's -25 plus, that is 5, I square root of 2 over 15. Now we can simplify by 5. So that is, if we simplify by 5, that is going to be -5. That's simplified by 5. That's just I square root of 2. And simplify by 5, that will be 3. If we separate the radical, I mean, if you separate the denominator, that's -5/3 plus square root of 2 over 3I. And final example here, that's going to be -3 minus square root, just I square root of 7 times -3 minus I square root of 7, right? And then we distribute this. That's positive 9. That's positive 3I square root of 7. It's positive 3I square root of 7. And then that is positive I squared square root of 49, right? Which would be 7. So this is I squared square root of 49. I squared is -1, and square root of 49 is 7. So that's -1 times 7, -7 plus 9. So that's 2. And then plus 6. Believe this is a 3i. It's 3i square root of 7. So that's 6i square root of 7. 6i. Let me fix this. So that is, this one is when we did that, right? So that is plus 3i, oh, no, plus 3i square root of 7. So then that's your final answer here.